Hi everyone, welcome to Cola Teaches Math. So today we're going to do my Unit 4 review on contextual derivatives, motion, related rates, linearization, L'Hopital's rules. So let's do it. Okay, so motion with the function is the particle at rest, right, left, and turn around. So we are at rest when velocity is equal to 0. We move right when velocity is positive, left when velocity is negative, and we turn around when velocity changes sign. So let's go ahead and do that. This is already the velocity function, so I'm going to factor it, t minus 6, t minus 2, set it equal to 0, and we get 2 and 6. So we are at rest at these points right here. And now if I want to see if we turn around, I'm going to make a number line, and I'm going to plug different values into the velocity function. I like to plug it into the factored form in my class. So if I'm doing a number smaller than 2, 0, this bubble is going to be negative. This is going to be negative, makes it positive. Let's do 3. If I do 3, negative, positive, negative. And let's do 7, positive, positive, positive. So we moved right, left, right. And we did, in fact, turn around here and here. Now, is the speed increasing or decreasing at time 3? So what we're going to do is we're going to compare the velocity and the acceleration at time 3. So we're going to do the velocity at time 3, the acceleration at time 3. So we're going to take the velocity at time 3 and plug it in. 3 squared minus 8 times 3 plus 12. And then we're going to do the same thing for acceleration. I'm going to do the acceleration function over here. It's 2t minus 8. So we're going to do 2 times 3 minus 8. So if we do this first one, it is 9 minus 24 plus 12, which is negative 3. And then this one is going to be negative 2. So since they're both negative, speed is going to be increasing. Because remember, for speed to be increasing, velocity and acceleration have to have the same sign. So they have to both be positive or both be negative. For speed to be decreasing, velocity and acceleration have to have opposite signs. Now, if I want intervals when speed's increasing or decreasing, that's when we're going to compare the number lines. So I'm going to take the number line for velocity, copy it, move it down here, move this, this, and this. And then I'm going to create a number line for acceleration. So we're going to set the acceleration function, 2t minus 8, equal to 0. And you're going to get t equals 4. So then I tell my kids, let's make a number line and put it in numerical order and see what happens on the other side of 4. So if we plug 0 into this, it's going to be negative. And if we plug 5 in, we're going to be positive. So now we can go ahead and kind of split over the times, and we're going to see if we're increasing or decreasing. So speed is increasing when they have the same sign. So where is that? 2 to 4 and 6 to infinity. Line it up. You can see the pluses and the minuses, how I lined it up. And then speed's going to be decreasing when we're less than 2, but I'm going to say 0 to 2 because I restricted the domain. 0 to 2, and where else? 4 to 6. And that is it. All right, what else do we need to be able to do? From a graph. So this is my velocity graph. And they want to know, same thing, rest, right, left, turn around. Well, particles at rest when velocity is equal to 0. So that happens right here at time equals 4. We are moving right when velocity is positive. Velocity is positive from here to here. So from 0 to 4. We are moving left when velocity is negative. So here. So from 4 to 9. You don't have to worry about the brackets. You can always use parentheses. And we turn around when velocity changes sign. And that happens at time 4. Okay, B is speed increasing or decreasing. So I like to go through section by section and label my graph. You can do the same thing or do whatever your teacher taught you. So watch how I color code this. So this first section right here, let's not use black, let's use green. The velocity is positive because it's physically above the x-axis, and the acceleration's positive. So acceleration's positive when velocity is increasing, because acceleration is the slope of velocity. This is a positive slope. All right, next section, this little guy right here. Velocity's still positive, but my acceleration's negative now because my slope is negative and we're decreasing. Here, velocity's negative, acceleration's negative. This doesn't matter because the acceleration's constant there. And this guy right here, velocity's negative, acceleration's positive. So now you can just go through each section and figure out, are we increasing or decreasing? So in this section right here, speed's increasing because they're the same sign. Speed's decreasing here, increasing here, then decreasing there. Okay? So you can break that out into the intervals in letter B. I just wrote it on the graph to save some time right now. All right, C, when is the acceleration positive? Well, I just wrote it on the graph. Acceleration's positive either when velocity is increasing, you could say it like that, or slope of velocity is positive. However you want to say it. So we're increasing from 0 to 2. And what is that, 8 to 9? Let me just. Okay. Now, displacement. Displacement is, it's the area under the curve with negatives. So this is what I mean. We're going to calculate the area of all these shapes right now. I'll write it in purple. So this triangle is going to be 1, 2, 3, 4. 4 times 2 is 8 divided by 4. Base times height divided by 2. I know this is a trapezoid, but in my class I like to split it up into triangles for my class. So this is going to be 2 times 2, negative 2. Base times height divided by 2. I'm just doing it in my head. Negative 2. And then this one's going to just be 1. It looks like it goes past 9, but I didn't want it to. This one's going to be 1 times negative 2, negative 1. So the displacement, we're going to keep all the signs. My advice to you is negate anything that is under the x-axis, like all the time. So if we add all these up, it's going to be 4 minus 2 minus 2 minus 1. So what is that? Negative 1. Now the total distance traveled is when you have to absolute value all the areas and add them up. Because this means I moved 4 steps to the right and I took 5 steps backwards. That's what this is saying. So my position I end up further to the left than where I started. So if we add all of these up with absolute value, my total steps that I took, 4 plus 2 plus 2 plus 1. So that is 9. Okay? All right, motion is big. Related rates. I love a good cone. I chose to do a cone in my review, but you have to know all the shapes. You have to know spheres, circles, cylinders, and triangles. So water in the tank has the shape of an inverted cone with base radius 2 centimeters. So I like to break out everything. The radius of the cone is 2, and the height of the cone is 4. If water is being pumped into the tank, dV dt, at a rate of 5, find the rate at which the water level is rising. So they want dH dt of the water when the water is 3 centimeters deep. So when the height of the water is 3. Now, notice that they didn't give me any information if about dRdt, okay? So, yeah, okay. I'm just gonna work this out. 1 minute. All right, so let's do it. I wrote all my givens down. Now, they didn't give us any information about dRdt, so if they don't give you a lot of information, you're going to use a proportion to eliminate R or H. So I tell my kids, if they want you to find dHdt, you're going to eliminate R. If they want you to find dRdt, you're going to eliminate H. So this is what I mean. You're going to make a proportion. One side is going to be the dimensions of the cone, 2/4, and the other side is going to be the dimensions of the water, R/H. The cone's not changing, the water is. So that's why we're going to leave the water as R/H. If I want to eliminate R, I'm going to solve for R here. If I solve for R, okay, I'm going to multiply both sides by H and I'm going to reduce. R is H/2. Just get R alone. So what I'm going to do now is I'm going to replace in my volume of a cone formula R, this black R, with H/2. So now watch. We're going to have 1/3 pi, instead of R, I'm writing H/2 squared H. Now if you want to watch me simplify this, you can, because we're not deriving from here. That's way too ugly. So I'm going to do 1/3 pi. H/2 squared is H squared over 4 times H. Well, if you simplify that, that's pi H cubed over 12, or pi over 12 H cubed. Next, we're going to derive this implicitly and plug in. So the derivative of V is 1 dV dt. These are numbers. So to derive this, we're just using the power rule. 3 times pi over 12 is 3 pi over 12, which is pi over 4. H squared dH dt. Now I like to check off what we know. We know the volume of the cone is changing at a rate of 5. We know the height of the water is 3. Sorry, the volume of the water I meant here. The height of the cone is 3, and they want me to find dH dt. If you have one thing circled, you are good to go. So let's plug in now. dB dt is 5, pi over 4. H is 3, dH dt. So if this was without a calculator, it would be 5 equals 9 pi over 4 dH dt. We do not divide by fractions, we multiply by reciprocals. So I'm going to multiply both sides by 4 over 9 pi. And then your final answer, I'll write it up here. dH dt is 20 over 9 pi. And my units would be cubic centimeters per minute. Not cubic centimeters, centimeters per minute. Minutes? Seconds, minutes. Centimeters per minute. Okay, so my units would be centimeters per minute. All right, next shape. Triangles. Love a good triangle. I like to draw a picture for a triangle. I always like to label it X, Y, and Z. And a 13-foot ladder is sliding down my house. By the time the base is 5 feet from my house, so here's my house, guys. My house is over here. Here's my house. By the time the base of the ladder, here's the ladder, this is the base right here, is 5 feet from my house, It's moving at a rate of 5 feet per second. So dx dt is 5. How fast is the top of the ladder going down the wall at that moment? So they want me to find dy dt. Well, dz dt is 0. The ladder is not changing its length. So what we're going to do now is we're going to use Pythagorean theorem, Pythagorean triples, to find what this is right here. Well, it's a 5, 12, 13 right triangle, so I know that this is going to be 12. Well, now I have all of my info. I'm only missing one thing. Start with Pythagorean theorem. Implicitly derive 2x dx dt plus 2y dy dt equals 2z dz dt. Check off what you know, circle what you don't. You know all of this, and now you can just plug in. 2 times 5 times 5 plus 2 times 12 dy dt equals 0. That whole other side is 0. So if you go ahead and solve that, that's 50 plus 24 dy dt equals 0. So dy dt is negative 50 over 24. It makes sense. It is sliding down the wall, which is why it's negative. All right, circles. They love to relate circumference and area, so let's see what we have. The circumference of the circle is 20 pi. Find the rate at which the area of the circle, dA dt, is changing at that instant. Okay, so I didn't give you enough information. And let's say dr dt is 2. So, starting with the area of the circle, area is pi r squared, because that's what they want you to find. Implicitly derive that so you can see what you need. dA dt is 2 pi r dr dt. Well, dr dt is given to you. They want you to find dA dt. You can find r by using their circumference formula. You need to know circumference is 2 pi r. So if you go ahead and solve this for r is going to be 10. Great, you know everything now. Let's plug it in. So we're going to have dA dt equals 2 pi 10 times 2. You can leave it like that. Done. Next thing in Unit 4 is linearization or linear approximation. So they give us the derivative and they want us to use the equation of the tangent line. So that's like really important. At the point 2, 2 to approximate when x is 0.8. So my tangent line equation is point slope. I use different form. Well, I use point slope. I just use different notation. So y minus f of a equals f prime of a times x minus a. This a is the x value. So I'm going to replace a with 2 so I can see what I need. Y minus f of 2 equals f prime of 2 times x minus 2. Next, we need to find f of 2 and f prime of 2. Well, f of 2 is the y value. So f of 2 is going to be y minus 2. Now, f prime means derivative. We have the derivative right here. So we're going to take the point 2, 2 and plug it into the derivative. 2 squared minus 1/2 times 2. 4 minus 1 is 3. On the free response, you need to show the tangent line in terms of x first, and then underneath you have to plug in 0.8. So now I'm going to plug in, so we need this first. Plug in 0.8, and if you don't want to do the decimals, because you don't have to on the free response, just add this 2 over, and your final answer is going to be this. You can leave it like this. Done. And last but not least, L'Hopital's rule. So L'Hopital's rule is used for indeterminate forms. When you plug in the limit and you get 0 over 0 or infinity over infinity. There's a ton more, but these are the ones that are tested on the AP exam. So basically it's saying if you plug the limit in, you get 0 over 0. You can try again with the derivative, but The trick is you have to show the limit of the numerator and the denominator on the AP to get full credit. So spoiler alert, if I plug in 0, you get 0 over 0. So now you need to show the limit of the numerator is 0, it is. And then you need to show the limit of the denominator. If you do that, that's e to the 0 minus 1 minus 0, which is 0. So L'Hopital's rule can be used, or L'Hopital's rule applies. What I'm going to do is I'm going to derive the top. Derive the bottom. And then I'm going to try again. So you get 0 over 0, you have to do it again. So we're going to go ahead and derive it again and try again. All right, next L'Hopital's rule example. I can see this is going to be 0 over 0, so break out the numerator. Show it's 0, sine of 0, 0, break out the denominator. Take the derivatives of the top and the bottom. The derivative of sine is cos. The derivative of the x is 1. And try again. So now if I evaluate this, the cosine of 0 is 1. 1 over 1 is 1. Okay, this one. I don't know. I think that's my 3. Is it? I don't know. Let's make it a 2. Okay, so here we go. If you plug in 1 right now, you're going to get 0 over 0. So I'm going to break that out. Limit as x approaches 1 of the numerator is 0. Limit of x approaches 1 of the denominator is 0. So now we're going to try again. We're going to take the derivative of the top, up to you. I'm actually going to distribute this through first. So when I take the derivative, I'm going to get 4x. The bottom, how do we derive ln? It's u prime over u. This is u. So u prime is 2x over x squared. You're going to want to reduce that to be 2 over x. Well, let's change flip this, okay? And then this is going to be 4x times x over 2. So that becomes 4x squared over 2, and we're going to take the limit of that as x approaches 1. We'll just plug in 1. You're going to get 2. And that is Unit 4 in a nutshell.